Hello everyone. Did you ever get an opportunity to get into the kernel source code? Or you have already looked into the kernel source code, somehow you are missing the bigger picture. So if your answer is yes to any of these questions, this video is for you. Hi everyone, I'm Pradeep Devani. I am a trainer, consultant and a mentor. Now we will right away jump into the kernel source code, the core topic. So I'll just be sharing my screen right away and let's get in. All right. So that is what we are here for, the kernel source over. So now in order to get the kernel source code, you need to visit the website kernel.org. From there, you can download the kernel source code. So let's say now you have downloaded the kernel source code. Let's now look into the high level view of the kernel source. Now, how does this kernel source looks like? So now you just need to think from the perspective of what all different tasks does the OS do. So we have already seen there are 5 management tasks being done by OS, and accordingly corresponding to that, Linus Torvald created 5 different folders. Okay, so you are going to see 5 different folders which will be corresponding to each of these management tasks. Now, the first thing which we have got is basically arc. So arc basically refers to something like a CPU or SoC. So that is basically your CPU. So the task of managing the CPU is what we call it as CPU management. Now, if you need to understand over here, now CPU management has 2 different, I can say layers. One is like where you manage that low level code, where you basically write the startup code and also that you are going to find over here. Apart from this, there is something called the scheduler, which basically manages the processes in the system. So you basically have something called shed.c file where you have the scheduling algorithm. So right now I am just showing you over here the arc folder. Inside the arc, you basically have the CPU dependent code. So that's why we call it as a CPU management task. Now, coming to the next important resource which we have in our system is something called the memory. So corresponding task, the corresponding management task is what we call it as a memory management. So that's a second folder which you will find in the kernel source code. Now coming to the third task. So the third task which you have got is something like a storage management. So as I told you, storage management means the persistent memory. Whenever you basically want to deal with your hard disk, the USBs, the CD-ROMs, or something like that, that means you want to read or write some persistent data, you basically need the storage management. Now this storage management, if you ask me, is being split into 2 parts. One of them is something like a FS, that means the file system, and another thing which you have got over here is the block. That means all the things related to like your block devices like ID hard disk, SATA hard disk or something like that. So now when it comes to file system, let's first understand what exactly is file system. So if you ask me, file system is nothing but the algorithm, the methods and the data structures which OS uses to access the files on the disk. So as you would have seen, like we have something called the FAT32 file system, NTFS file system, ext2, ext3, ext4, and all those kind of things. So what are these? These are nothing but the algorithms, and these algorithms we typically call them as a file system. Now coming to the part two of this, where we basically have got the block. Now what is basically the block? Block is something like you have to access the hard disk over the SATA protocol or over the ID protocol or something like that. So those level of things you will find over here. But remember over here, again, there is one thing. Typically in the Linux kernel source code, what we have is we have something like where we factor out the common code from the hardware specific part. So this block will have the hardware specific part under the driver. So here what I'm showing you is basically again more from the perspective of how do you basically uh, provide the framework for the block layer, separating out all the common code. So that hardware independent part is basically over here in the block. Now, moving on, the next thing which we have got is a net. So basically the network management part of it. So when I say again over here, if you ask me, the net is nothing but the hardware independent part. Say for example, the TCP IP stack or network management layer and all those kind of things will be here. Now, coming to the final part is something like a drivers. So under the drivers, you basically have a care where majority of your IO management is done. So that is the fifth task which OS does. Now, as I was telling you, basically corresponding to this net and the block, you will find the corresponding hardware dependent things. So those you are going to find out over here, you see MTD ID. So that is basically the hardware dependent. Basically, you will be dealing with that actual device. So the driver for that will be here. So this is actually not a driver. This is more like a framework, block framework. Now, apart from this, what you have is a net. So this is where you will find the drivers for the Ethernet card, PCI based Ethernet card, or whatever dongle you might be using. So all those kind of things, the hardware specific part will be located here. Okay. So now next, if you see, you have something called init. Now, what is init? So, as you understand over here, init is nothing but something where you do the initialization of the kernel. So, under the init, there will be one file by name main.c where you do the complete initialization of the kernel. So, as the name itself suggests, init means initialization. So, during the boot up, this init has one function called the start kernel, which I'm going to show you in a little while, and that is the one which will be doing majority of the initialization. Apart from this, what we have got is the kernel folder. Now, this is very important folder from the kernel writers for the kernel developers or the driver developers perspective, because it contains most of the important stuff for the kernel developers. So for example, I can say print k definition, you will find it over here. And another thing is, let's say, for example, the wait queues and all those things which you will be dealing, the programming constructs, all of them you are going to find over here. So that is the purpose of this kernel folder. Moving on, what you will have got is IPC. Now, one thing which you need to understand, this IPC is not like managing the processes in the kernel, because kernel is a monolithic. Linux kernel is a monolithic. So you don't have the multiple processes. So what you have is this will provide all the facilities for user space to have the inter-process communication. So those all things you are going to find it over here. Now, moving on, another part which you have got over here is the lib. Now, what is lib? As the name itself suggests, lib stands for the library. So all the commonly used functions, for example, strcat, strtalk, and all those kind of functions which are commonly used, they are being placed under lib folder. Now over here, you might have a query. Uh, why do we need to include the lib over here when we have in the user space? So actually speaking, kernel doesn't use anything from the user space libraries. Kernel is self-contained. So whenever the kernel was developed, all these basically functions were rewritten. So you can have a look at lib. You will find many common functions, many common files which might be there in the user space. But beware, these files are not just being copy pasted. The kernel developers have rewritten it as per their needs. Now moving on, what you have is the include. So include again is for the prototypes, the .h which you will be using during your kernel. So during your driver and all those kind of thing. So all the prototypes and everything will be stored here. So that is what is the purpose of include. And now, apart from this, you have a PCI, serial, USB, and all those kind of other drivers as well, other subsystems as well. Further to this, what we have got is some scripts and tools, and then we have got something called a crypto kernel, a crypto firmware, security, sound, and all those kind of things. Okay, so this is like a very high level view of the Linux kernel source code. And now it's the time to take the actions. Okay, so what I want you guys to do over here is the action items. First, download the kernel source from kernel.org. So you need to go to the website kernel.org and you need to download the source code and you need to observe these five directories. That means corresponding to this management task, the arc, the the fs, then the block, net, care, all those things basically I want you to observe. And then you need to look into the init main.c. Okay, so let me just quickly show you that stuff, init main.c. So, so here what we have is one of them is arc, another one is basically the another one is fs, block, net. Okay, and drivers. So you need to basically dig into these directories, and now I will show you init main.c, init main.c, where your initializations are done. So we have something called start kernel over here. So this is the function which I want you to look into in detailed manner. Okay, so I can say like you don't need to jump inside the functions, but just understand at a very high level what exactly it is doing. You see, basically you would have seen this message being coming when your kernel boots up, kernel command line. So it is coming from here. Then booting kernel also you will observe this particular message coming. So whenever the kernel boots up, just observe these messages and it will give you a very good idea about the kernel. Okay, so this is one of the action item. Next, what I want you to do is look into the kernel directory. So I was telling you directory is basically the home for the kernel programmer or the driver developer. So you see, right, there are lot many functions over here. So you see the print k, which we are using, it's here. And apart from this, what you will see is shed. I was talking of the scheduler related stuff. So it will be you will be finding over here the scheduler, which is involved in your all this. So all this scheduling algorithms are here. You see deadline based, fair based, uh, CFS scheduler. So all those things you will be finding it over here. Okay, so look into the kernel folder. It's very interesting to look into. So for example, I was telling you over here the work queues which we are using. You will find the definition for them over here. Apart from this, you can look into the lib. So in lib, you see you have got your familiar string.c, something like that. So all the commonly used functions will be available as a library over here. So do look into this things. It's going to give you lots of things. So with that, we are done with a high level overview of this kernel source code. Thank you very much, guys, for tuning in to basically comment on this. Just put something, but just you can let me know like how did you whether you like this video and what all things you need to see in a further videos. And another thing is there are some groups which I basically keep on posting the useful articles, so you can join in those WhatsApp group. Bye bye guys, thank you very much.